Welcome back. In the next part of the lab, we are going to use the watershed function in the Spatial Analyst toolbox here, Spatial Analyst, Hydrology, Watershed, to actually use ArcGIS to derive a watershed, and then we're going to compare that with our hand-drawn watershed. So if you open up this watershed tool, you will see that ArcGIS requires a flow direction raster and a pourpoint data point. And the pourpoint is the location of the outlet of the watershed, and I've provided that for you for this particular example. The outlet for 3_m, meaning it's a 3-meter DEM, 3-meter resolution DEM. So if you do this on your own and create your own watershed for a different area of this quadrangle, that would be great. You're going to have to create your own pourpoint using the drawing tool. So you would go to drawing tool, and pick the marker tool and create a pourpoint. That process of generating that watershed can be a bit iterative, so just be prepared when you go ahead and do that. But back to our regularly scheduled program. We need to create a flow direction raster from this Laguna Beach DEM, which has already been filled, so we can go ahead and select flow direction. And I'm going to pick lag 3M, and I'm going to call it FD 3M and then underscore D8, because I'm going to use D8 for the flow direction type here. And it's flow direction on the 3-meter DEM type D8, and I'm going to click OK. Okay, so now once I have my flow direction raster, I can go back into my watershed tool, and my flow direction will be flow direction. My input pourpoint will be the outlet for 3M. I can leave this pourpoint field optional. There's no other fields in that shapefile, so we can leave that as is. But the output raster, we're going to call it just shed. It's the ArcGIS derived. It's going to be a raster of this watershed. So I'm going to click OK. And the result will be, I'm going to turn off the hand-drawn watershed and the flow direction, and we have a raster grid where everything that's incorporated inside the watershed is coded as 0 and everything else is no data. So you essentially have a watershed that was derived from the Laguna Beach DEM via the flow direction grid. So now what we want to do is compare this ArcGIS generated watershed with the hand-drawn watershed. But to do that, we need to convert it to a polygon. So we're going to go into our conversion tools and go from raster to polygon. And the input raster will be shed, and the value will be the field. Let's just make sure that it's value, because that way the value in that table in the grid is 0. And count would be the number of zeros, so you don't want that as your polygon value. You just want to have the 1 0 as the value, and then it will make one polygon. And we will call this ArcShed, so that we know that it was derived from ArcGIS. So we'll call it the ArcShed. and the result is a polygon that represents the computer-derived watershed. And what we want to do next is compare the computer-derived watershed with the hand-drawn watershed. We can see that we have areas that are in common, areas that are not in common, so we want to actually quantify those differences. Before we do that, let's go back into our ArcShed, open its attribute table, and we're going to add a field called km², so we can calculate its area. And we will make that a float. And we'll calculate geometry to calculate the area of the ArcShed in square kilometers. And we also want to add a field, and we'll call it label, like we did with the other shapefile. We will make this a text. And this one, we will right-click and go to Field Calculator, and we will call it Arc, in quotes, GIS derived watershed, or something like that. Let's call it that. And now we are ready to compare these two watersheds quantitatively as well as visually. My other recommendation before you do that is to just go in and compare these areas. It's 0.5537 in the hand-drawn watershed versus 0.588, so they're a little bit different in square kilometers, and we will explore that further in the next step.